When you're at sea on a sailboat, calculating the true wind can be an important task. Two ways to do it are with the maneuvering board and the Vectormaster by Weems and Plath. We'll go over both of those in this video. There are three definitions of wind we need to talk about first. The first one is relative wind. The relative wind is just what you would describe the wind doing relative to your own ship. So regardless of the course that your ship is on, if the wind is 30 degrees off the starboard bow, the relative wind is 030, or 30 degrees off the starboard bow. If you kind of add in the element of your course, you can calculate what's known as the apparent wind. So in this case, the relative wind is still 30 degrees off the starboard bow. But since our course is 045 degrees true, our ship is heading 045 degrees true, the apparent wind is 30 degrees to the right of our heading, or therefore 075 degrees true. So in this case, you're overlaying your ship onto a compass or a map of the world, and you can see that the wind is coming from a real compass direction of 075 degrees true. It all depends on your heading and the relative wind. So the relative wind feeds into the apparent wind when you add your course into it. The final type of wind we'll talk about is the true wind. And the true wind is one more step in the process. In this case, we're taking not just the direction, but the intensities as well. So in this case, the wind is 30 degrees off of our starboard bow, but maybe we notice that it's at 10 knots. We can read that off of an instrument known as an anemometer. Our ship, again, is heading on a heading of 045 degrees true, but maybe we're moving 5 knots. The big picture of what happens when you calculate the true wind is you take your ship from the middle, you calculate a vector of 5 knots on a course of 045, and then you take this wind vector. You go tip to tail, 10 knots in a direction parallel to 030 for 10, and then whatever's left is your true wind. So you go backwards from this, and out here will be your true wind direction. So what we did there is we have our ship's heading 045 at 5 knots. We did a tip to tail method with our wind parallel to 030 relative at 10 knots. We kind of carry that out. The remaining vector from this way to this way is the true wind. And you can measure the intensity of it by measuring that vector there. So the direction is from out here, and the intensity is whatever that value is. Let's try and quantify that on what's known as a maneuvering board. You can use these maneuvering boards to calculate the true wind anytime you've got the certain amount of information. So in this case, our course is 270, our speed is 7 knots, and our relative wind is 045 degrees off the starboard bow. So it's kind of coming off of our starboard bow in that case. And it's coming at a speed of 20 knots. Maybe we noticed that on the anemometer, maybe it's an estimate. The maneuvering board has the feature of scales as well. So in this case, since the wind is so strong, 20 knots, I'm going to use the 2-to-1 scale. Our ship is on a course of 270 degrees true. So I can draw that line out. And we're going 7 knots. So I can go over to the 2-to-1 scale, measure off 7, and place a mark along this vector. Our traditional notation is going to be E to R for hour, course, and speed. We're going 270 degrees true at 7 knots on a 2-to-1 scale. The next thing that I would do is kind of calculate the relative and the apparent wind. Well, the relative wind is 45 degrees off of our starboard bow. So if this is our bow, 10, 20, 30, 40, 45. The relative wind is coming from somewhere up in that direction. If I wanted to quantify that and turn it into an apparent wind, I just take that relative direction and I give it a compass value. It's going to be 315 in this case. True. It's not very helpful in real life, but it is helpful for the math here. The way that I go about calculating the true wind is I take this vector that's kind of coming from the sky towards us, and then I'm going to parallel it over to the R. And I'm just going to draw out a line like that, right? So we've got the apparent wind here, and we're parallel to that from our hour vector. So if you remember back to our scrap piece of paper. We went from our relative wind to our apparent wind, and now we're looking for our true wind by quantifying things. We said in this example that the apparent wind, or the relative wind, was at a speed of 20 knots. That's a lot. So if I take my dividers and I go over to my 2-to-1 scale, I can look for 20 knots. There we go. I can reverse it over here, make a mark, and now I can mark that off, put the W in, and I've got the relative wind vector. It was from this direction, goes in that direction for a distance of 20 knots on the 2-to-1 scale. Whatever's left is going to be our true wind. So I connect E to W, connect the E to W. It's easy to get confused doing this. I connect the E to W, but the true wind is actually from up here. Right? Winds blow from a direction, so it comes from up here, over me, and then goes out into the world that way. Right? Another way to remember it, if this was our bow up here, the true wind is always on the same side, but aft of the apparent wind on a ship that's moving forward. How do I quantify this wind? Well, I'm going to measure it here, take it to the 2-to-1 scale, and I would say that it's a little less than 16 knots. So the true wind is 16 knots from about 333 degrees true. And that's what can go into the logbook. The true wind is from 333 at 16 knots. I remember the acronym WET, wet, blows from the T through us and then out into the sky. We've got another tool that we can use for this, which is the Vectormaster. The Vectormaster is a handy way of doing these kind of vector analyses just in a little handheld device. So we'll zoom in on here, and the gist of the Vectormaster is that you've got all of this written stuff in these movable rings. So in the front, you've got a ring that can move this way, and in the back, you've got another ring that can move that way. So you can kind of twist these all around and get dizzy doing it. But in all seriousness, the first thing that you would do in this case is turn the inner ring to 270. That's our ship's course. Right? So along the outer ring, you can see the true bearings. On the inner ring, you can see your relative bearings. Our relative bearing in that case is dead ahead is 000, should match up with 270. The next thing you're going to want to do is you're going to want to count out these little red rings for your speed. So if we're going 7 knots, I'm going to start in the middle, and the little button ring is 1, 2, 3, 4, 5, 6, 7. And I'm going to put a mark right there. And I'm using big markers, so if you get a slightly different answer, that's okay. From there, you take the apparent wind, or the relative wind, whatever you're given, and you're going to spin the little back ring right here. Right? And so in our case, the relative wind was 45 degrees off our starboard bow, or the apparent wind was 315. So whichever information you have, you can kind of make that work. So I'm just spinning this 10, 20, 30, 45. Right? So we've got the apparent wind 45, or the relative wind 45 degrees off our starboard bow, but at the same time, the apparent wind is 315 on the outside. So you can kind of do both things at the same time. Finally, that wind was at 20 knots. So what you're going to want to do is see all these lines that are kind of parallel here. Those lines. That's the way that the wind is blowing, apparently, to you. So find your black dot where you were and just count 20 little marks all the way down. And you can do 5, 10, 15, 20. Place another mark. Right, so I just kind of went in a parallel direction, 5, 10, 15, 20 for the distance. The last little thing to do, and I'm going to erase these teaching marks here for a second, is spin that inner ring so that the big black line touches your secondary point there. Go backwards up here, and that number right there is where the true wind is coming from, about 331 degrees true. So either way, we got similar results using the maneuvering board and the Vectormaster. So the process for the Vectormaster, once again, is kind of start out with everything at 0, spin the inner ring to your ship's heading, 270, make a mark for your ship's speed, 7 units away from the middle, spin the back ring until it's giving you your relative or apparent wind, 0.45 in that case. Count out 20 units in a direction kind of parallel to your mark here. And then the last thing to do is just spin the black line until it intersects your secondary point and go backwards up to get the true wind that way. And that can go into the log. 330 degrees true, and you can count out the little units. We've got 5, 10, about 15, about 16 units in that case, right? And that's exactly what we got when we did the maneuvering board as well. Let's do another example. In this case, our ship is heading on a course of 030 degrees true at a speed of 4 knots. Sounds like a sailboat to me. Our relative wind is 110 degrees off of our port bow, and the relative wind speed is 8 knots. What is the true wind speed in this case? We'll move through this example fairly quickly. The first thing we're going to do is want to plot out our course and our speed. We're on a course of 030, and we're at a speed of 4 knots. We can use the 1-to-1 scale in this case. I like to use the vectors E to R to stay in touch. The relative wind is 110 degrees off our port bow. So if this is our bow, 10, 20, 30, all the way over, where's 110? Well, here's a quick way to do it. Either some math, or you could say that's 90 degrees, 100, 110 degrees from there. So our apparent wind is blowing from that direction. Right? It's also blowing at a speed of 8 knots. So what I'm going to do is take this line right here, the apparent wind line, I'm going to parallel it up to the R point and draw that out quite a ways. It's okay to go off the circle. The relative wind is at 8 knots. So I'm going to measure 8. 1, 2, 3, 4, 5, 6, 7, 8. Quantify that. Put a dot. Call it W. And then the true wind is going to be W-E-T. The true wind is blowing from here over me and then out into the distance. Remember, the true wind is always on the same side, but aft of the apparent wind. So the true wind looks like it's coming from about 260 degrees true, and the distance is equivalent to the speed. And it's about 9.9 knots. We'll call it 10 knots. How about that? So that's a quick and dirty maneuvering board given the course, the speed, and the relative wind off of our anemometer. Can we do the same thing with our Vectormaster? Spoiler, yes we can. All right, so our course was 030, so I'm going to twist that over to 030. All right, and we'll zoom in for you here. And our speed was 4 knots. So I go 1 for the circular ring, 2, 3, 4. So I make a mark right there, 4 knots. The apparent wind was 110 degrees off the port bow. So here's 10, 20, 30, 40, etc., all the way over to right there. Another way to do that is you can just kind of count 90 and then count another 10 if you want. Or you could do some math and say 360 minus 110 is 250. So here is our spun dial to account for the relative wind. And we said that the relative wind was at 8 knots. So we're going to go kind of parallel to that black line right here. We're going to just kind of count out 8. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, about there. All right, just along that parallel line. I'm going to erase those teaching marks for a moment. Last thing we do, spin the big black line so that it comes in line with your secondary point, U, and then whatever number comes out the backside is going to be your true wind. 260, right? We said 260. And the speed is equivalent to the number of units between here. So we've got 5, 10 units. Same as that. So the Vectormaster is a great way to kind of solve maneuvering board problems or wind problems if you don't have a maneuvering board, or even if you prefer the Vectormaster. So again, the way that we did this one, we kind of start out with everything in the middle, spin the inner ring to our ship's course and speed, 30 degrees, speed of 4, make a mark. Spin the back ring until it's 110 degrees off of your heading. All right. And then kind of count the parallel units equivalent to the relative wind. 1, 2, 3, 4, 5, 6, 7, 8. Put a mark. Spin the black line until it comes through your secondary mark, then U, and then the true wind is out there. 260 at 5, 10 knots. So that's a little overview of how to use the Vectormaster and relative, apparent, and true winds and the maneuvering board. Good luck.